Good evening, ladies and gentlemen. This is my idle air control valve from my 1999 Honda Odyssey. The idle is doing the classic going up too high and then dropping too low and bouncing back and forth between maybe 2,000 and 1,500 or so RPM. So I took this off of the car without taking anything else off. This was mounted underneath the air intake throttle body. It was held on by two screws. Here's one of them. I used this little gadget, 1/4-inch wrench, a number 2 Phillips head screwdriver bit wrapped with tape to hold it on. It's a tight working environment there, and you can't see it, so you're working blind. I reached under the throttle body, and this was there. I was able to feel with my finger and push on the head of this screw to leave a Phillips head mark to prove to myself I was at the location of that screw. I then reached under and fitted this onto the screw head and then turned it clockwise, as from my view from the top, which would then, if you were able to look from the bottom, would be turning it the lefty-loosey counterclockwise to loosen that screw. Likewise, I did it for this, which was closer to me as I faced the front of the engine. I then had to fight with a miniature hose clamp, which I pinched shut with pliers, long needle nose pliers, and moved it out of the way, and then gripped the hose and turned it to break it had sealed itself to the surface of this metal, and I gently but firmly turned that hose to break its bond to there, so then I could wiggle it loose, and here we are with my idle air control valve. 3 compartments. One is for warm or hot coolant, engine coolant, to flow into there and then leave by probably the other mating surface has a place for that coolant to leave. And then this airflow entry and possibly exit, one of them's entry, one of them's exit, not sure which right now, allows a certain amount of air to flow, which is adjustable. As you rotate this, you can, let me see if we can get the light lined up there, you can see something going on inside, which if you put your mouth over this and blow, as I will now do, you can see as I rotated that back and forth, I was able to restrict the airflow, which you could hear, and let it move more freely. Now this metal cylinder, let's see what happens if I put my metal wrench near it. It appears to be quite magnetic. Quite magnetic, yes. Now the part that attaches to there, you can see there's 3 electrical pins to bring voltage and current to flow. And then this fits into that hole here. There's a tang on this magnetic cylinder, and that tang sticks into the furthest region of that hole, and it will bump against a protrusion down there, allowing it to move basically from about here all the way to about here before it bumps into the protrusion down there. So it limits it doesn't let this thing spin 360 degrees. It lets it go from some kind of zero position to one side or the other, depending on some kind of current flow in here. Well, let's kind of look at this molding body to see if we can make sense of some of this. This round part here to me looks like a coil or several coils of wire. And usually to magnetize something, they often will use a built-up, like these thin plates of steel, to create this path of iron that goes through the coil, comes up here, and then presents itself to the round hole where that magnet cylinder goes into. So I believe there's some kind of, when there's no current flowing in this coil, there'd be some zero position that this is held in, and then to move it from that zero position, you can have an increasing amount of DC current in one of the other pins, or pulses of current, which would average out to a certain amount of magnetism to pull this one way or the other. If you put your ohm meter on these leads, the digital ohm meter usually reads high mega ohms. It's because there's some diodes in series with that. So if you switch it over to the diode scale, depending on how you position it, there's some classic 0.6 volts or so voltage measured, indicating the diodes in the circuit. Diodes are sometimes used to suppress voltage spikes when you turn on and off voltage to a coil. But I'm going to assume that's not broken, because when I reached in there with some cotton swabs, after I squirted some WD-40 and let it soak, you can see the what I got from wiping it gently but obviously firmly back and forth in that slot as I take a clean one, reaching in there to clean it. Okay, let me also tell you about this thing, how this mounts onto here. You can see the slots for the screw has a fair range. So before I took it off, I noticed two lines on the injection molding of this black plastic, and then I made a couple scratches. You see the scratches with a sharp object so that I could realign whatever factory set position this had before I undid the screws. These screws are not meant to be taken off by the consumer, so the choice of bolt head is a 5-point Torx head, and with a little research and typing some keywords into Amazon or eBay, you can discover that they're called TS, and TS20 appears to be what my screw head is. So that's how I was able to get those loose without having to do the typical saw slot in the top of your screw head. What, about $8 or so for a set there. A set of 10 5-point Torx bits. So that screws in there, and you just to put it back together, I think you put that tang more towards the top, because the blocking part is going to be on the bottom. So bear with me while I do this one-handed. I'll put that in there. There. You can feel that magnetism pull that together. And I'll line those up. Put those screws back in. Tighten them up. And I'm ready to put it back on the car after I do all that. And hope it improves my idle. If not, I ordered a brand new one for $20, a Chinese knockoff, but boy, I sure do value the name of Denso on my original equipment part. So if I can get this running, I might just let it keep on doing its job. So I imagine to put this back together, since I did it by the non-mechanic standard of, leaving the throttle body there intact on the engine, I'm going to probably get under there with a dental mirror or mirrors, or maybe even a boroscope, and just look at the gasket, or at least feel the surface of the gasket, which is a rubber style, O-ring style rubber sealing gasket, which is very nice. Honda does this in many places in its engine. O-ring rubber gasket, which comes apart and is still pretty much just as good to be put back together. You don't have to sit there and scrape off old gasket material. Puts mechanics out of a job in some respects, but at least it allows this thing to go back together fairly easy. I guess I could put a very fine coating of some kind of gasket material on there if I felt like it. Or I could just make the thing together and check for leaks. So that's my idle air control job with only taking out 2 screws and 1 hose connection, because I was too lazy and too forgetful to take all that stuff off I was seeing in the other videos. Thank you for watching.